Today we're looking at the area of triangles and quadrilaterals. Your essential question is, how do I find the area of triangles and quadrilaterals? Your learning intention, I'm learning to find the area of polygons. You've got two warm-up questions. If you notice, your vertex here is inside the circle and the vertex here is outside the circle. Do you remember what to do? Pause the video and see if you can do those on your own now. Well, I hope you paused the video and I hope you tried. If it is inside the circle, you add the arcs together and divide by 2. So that means I take 140 plus 54 and I'll divide it in half. $140 plus 54 is 194. Divide it in half, and I will get 97 degrees. And I am correct. I went ahead and did the math on the calculator to check my answer. And we know that both these two angles are 97 degrees. They're vertical angles and they are congruent. When they're in the middle, you add them together and divide by 2. If they're on the circle, you divided that intercepted arc by 2. If they're outside, what do? We subtract and divide by 2. So we'll subtract these two, and that will equal, we'll divide it by 2, and that will equal 4x minus 9. So 12x minus 58 degrees divided by 2 is equal to 4x minus 9. Now there's different ways to get started. If you're thinking logically, 12 and 58 are both even, so I can divide them by 2 and get a whole number. 12x divided by 2 is 6x minus 58 divided by 2. 58 divided by 2 is 29, is equal to 4x minus 9. Now we need to solve. Going to start by subtracting 4x from both sides. (2x minus 29) is equal to negative 9. I will add 29 to both sides. 2x is equal to 20. Divide by 2. And x is equal to 10. So x is equal to 10. 4 times 10 minus 9 would be 40 minus 9, which would be 31 degrees. 12 times 9, that would be 90 plus 180 would give me 108 degrees. We found everything we can find. This brings us to the area of a circle. The area of a triangle. A triangle could be thought of as half of a rectangle. We know the area of a rectangle is base times height. So for a triangle, it becomes base times height divided by 2. Or multiplied by 1/2, either one. So the things you have to know, what is my base, what is my height? Okay, if I'm looking for my base here, here's the 90-degree angle, 16 will be your base. If I'm looking at the height, once again, I look for that 90-degree angle, and it is 6. So my area becomes 16 times 6 times 1/2, or 16 times 6 divided by 2. 16 times 6, then I'm going to divide by 2, and I get 48. Now this is yards squared, because you're looking at length times width. Okay, what about the next one? What will our base be and what will our height be? If we're looking at this, our base is 5. Our height is 15.4. Because there's where the 90-degree, we're always looking for that 90-degree angle for our base and our height. So our area becomes 5 times 15.4 divided by 2. 5 times 15.4 divided by 2, and I end up with 38.5. 38 and a half. That would be centimeters squared. We always have to put the correct units on our problems in geometry. So hopefully that was just a little bit of a review. Now the next one is kind of different. If you notice, you have the area and you are looking for the base. We still use the same formula. So our area, which is 108 degrees, is equal to my base, which is what I'm looking for, times my 12, which is my height, divided by 2. Okay, if I want to get rid of my fraction, I'm going to multiply both sides by 2. 108 times 2 would be 216, and that will equal 12b. b times 12 is 12b. Now, I'm going to divide both sides by 12, and b is equal to 18. And that would be inches. This time we don't have to square it because a length is in inches or yards or feet or whatever. It's not to the second power. But area is to the second power. So if we're looking at this quadrilateral, this is a parallelogram. The formula is your base times your height. Once again, you have to know your base, you have to know your height. So if I'm looking at this, my base is what? 91.2. My height is 7 feet. That height has got to be on the perpendicular to the base. It's the length of the segment that is perpendicular to your base to the top of it. So for my area, 91.2 times 7. Grabbing a calculator, and I get 638.4. 638 and 4/10. And this is inches squared. Length times width, that's 2 dimensions, so it is to the units squared. What if it's a square? What if all those sides are the same? Well, the area is simply side squared. So this area would be 5.1 squared. Putting it into the calculator, it's 26.01, 26 and 1/100ths. And I'm looking, this is in miles, so this will be miles squared. The area of a parallelogram is 180 yards squared. If the base is 15 yards, what is the length of the height? Setting up our equation. Area, 180 degrees or yards squared, is equal to my base, which is 15, times my height, which is h. Divide both sides by 15. Okay, 180. Divide it by 15, and I end up with 12. So my height will be 12, and that will be yards. So let's look at the area of a trapezoid. A trapezoid is a quadrilateral with only one pair of parallel sides. So if you look at the formula, it's 1/2 of the both bases added together times the height, which means I'm looking for the average of the two bases. I'm adding their lengths together and then dividing by 2. So let's apply this. If I'm looking at the picture, does it matter which one is my base 1 and base 2? No, because I could flip it over. For simplicity, this is base 1, this is base 2. The 2 is my what? Is my height. So this becomes 1/2 of 2 plus 4 times 2. So 1/2 of 2 plus 4 is 6 times 2. 1/2 of 6 is 3 times 2, which gives me 6, and that would be 6 inches. Whoops, that's a horrible 6. 6 inches squared. Going to the next one. I'm going to pause the video and see if you can do the next one on your own. Did you identify your base 1? Did you identify your base 2? And then put it into the formula. We'll call this base 1. This will be base 2. And the last thing we have to know is our height. Putting it into our formula, our area is equal to 1/2 of 7 plus 1.8 times 5.4. My area is 1/2 of 7 plus 1.8 would be 8.8. Times 5.4. 1/2 of 8.8 would be 4.4 times 5.4. Now we could do this with long multiplication, or we can do it with a calculator. and we end up with 27 and 76 hundredths. 23 and 76 hundredths. And this will be kilometers squared. Now, if we know the area and we know one base and the height, how in the world do we find that other base? Well, let's set it up. 50 is equal to, this time instead of multiplying, well, I can do 1/2. 1/2 of, base 1 is 9 plus base 2 times 5. To get rid of my 1/2, what do I multiply by? I'll multiply by 2. So 100 is equal to 9 plus my base times 5. Now I'm going to multiply by 5. I've multiplied by 5. I need to divide by 5. (100) divided in 5 pieces is 20. 20 is equal to 9 plus b. Subtract 9 from both sides. 20 minus 9 is 11. 11 is my other base. If we put it back in here, 9 plus 11 is 20. Half of 20 is 10. 10 times 5 is 50. It is correct. The last one we're looking at is the area of a regular polygon. If you remember, a regular polygon has all of the sides are congruent and all of the angles are congruent. So to find its area, we take 1/2 AP, where A is the apothem. I always think of the apothem kind of like the radius of a circle, and P is your perimeter. So let's look at how we can work with these. This will be my apothem, and this will be one side. So 1/2, and then it will be times 5.1, which is my apothem. How do we find the perimeter if they're all the same? Count the number of sides and multiply by the length of one side. I've got 1, 2, 3, 4, 5 times 5 times 7.5. Okay, when we're looking at the apothem, once again, we're looking at that. It goes from the center to the middle of an outside edge. So as I put this all in, I'm going to put 0.5, because that's the equivalent decimal to 1/2, times 5.1 times 5 times 7.5, 7.5, and I get 95 and 625 thousandths. That's 625, not 8. 95 and 625 thousandths. And this will be, it's not, we don't know what units that we're in, so it will be units squared. Pause the video. Can you do the last one now? Can you find your apothem? Can you count the sides? Multiply. Pause the video. Well, I do hope you tried. This middle will be the apothem. This will be the length of one side. 1, 2, 3, 4, 5, 6. I've got 6 sides. Putting it all together, my area is equal to 1/2 of 5 square root of 3 times 1, 2, 3, 4, 5, 6 times 10. Now, I need to multiply 1/2 times 5 times 6 times 10. And I will still have the square root of 3 left over. Remember, multiplication is commutative. 5 square root of 3 is 5 times the square root of 3. So as I'm looking at it, this is going to be 30 times 10, which is 300. 1/2 of 300 is 150. 0.5 times 5 times 6 times 10. 150. (150) square root of 3. This will be units squared. This is the exact. I could always put it in and find the approximation if I wanted to, but we're going to leave it as an exact with that radical in it. So how do you know you're successful? When you can find the area of triangles, quadrilaterals, or actually any figure. What formula do we use? It depends on what polygon we have. So we're always having to think about what we have and what formula to